Hello everyone, this video is regarding transformer phasor diagram at different load. And before directly going to the phasor diagram, we have to be familiar with the equivalent circuit of the transformer. This figure shows the equivalent circuit of a single phase transformer. And from the diagram, it is clear that induced EMF in the primary side is E1, which will be in direct opposition with applied voltage V1. Hence, we can write that V1 is equal to minus E1. The negative sign is for representing E1 is in direct opposition with V1. So, we can write the equation as V1 is equal to minus E1 plus drop across Z1, drop across these two parameters R1 and X1. Voltage drop across R1 is I1 into R1 and voltage drop across X1 is I1 into JX1. So we can write it as minus E1 plus I1 Z1. Then coming to the secondary side, from the equivalent circuit, from the exact equivalent circuit, it is clear that consider the secondary side. So V2 is equal to induced EMF in secondary E2 minus voltage drop, current flows in this direction. So induced EMF E2 minus voltage drop across Z2, that is minus I2 into R2 and I2 into JX2. Or we can write it as E2 minus I2 Z2. So while drawing the phasor diagram, these two equations are very important. Now let's move to the phasor diagram. First, let's consider the phasor diagram for purely resistive load. And the load is purely resistive. If the load is purely resistive, current through the secondary winding and voltage across the load will be in same phase, but the power factor will be unity. So it is otherwise known as UPF load. So let's start drawing the phasor diagram. Phi in x-axis, flux phi. And we know that both the induced EMFs E1 and E2 will lag the flux by 90 degrees. So E1 and E2 will be like this. So here we will get both E1 and E2. Now let's consider this minus E1. We have E1 here, and in order to get minus E1, extend E1 to the negative side. Extend E1 to the negative side. This is minus E1. Okay. Now we have to draw the no load current I0. Here I1 is the current through the primary winding. This I1 will have two components. One component I0 will flow through R0 and X0. This is for meeting the core loss and magnetizing the Then another component I2 dash. I2 dash is the load component of primary current. So we have to draw I0 and I2 dash. From this diagram it is clear that I1 is the vector sum of or algebraic sum of I0 and I2 dash. So we have to draw both the phasors I0 and I2 dash, and then we have to draw the primary current I1. Now I am going to draw the no load current I0. No load current I0 will be like this. It will lag E1 by an angle less than 90 degree. This angle of lag, this will be between 0 and 90. Now this I0 can be split into two perpendicular components. One component IW in same direction with E1 and another component IM in x-axis. IM is the magnetizing component which is used for magnetize the core, and IW is the core loss component. IW is known as core loss component or iron loss component, or it is known as working component of I0. Now draw V2, load voltage across the load. I am drawing V2 like this. Now we have to draw I2. So before drawing I2, check the load. Here we are considering resistive load or UPF load. The load is a pure resistor, or power factor is unity power factor. So V2 and I2 will be in phase. Voltage across the load and current through the load will be in phase because it is a purely resistive load. So I2 will be in phase with V2. Now we have to draw I2 dash. In order to get I2 dash, extend I2 to the negative side. Extend I2 to the negative side. Then we will get I2 dash. Now we know that resultant of I0 and I2 dash is, this is I2 dash. Resultant of I0 and I2 dash is the primary current I1. So now we have to draw the resultant of this I0 and I2 dash. In order to draw resultant, construct a parallelogram with sides I0 and I2 dash. Now I have constructed a parallelogram, and one side of the parallelogram is I0 and another side is I2 dash. Hence, diagonal of this parallelogram will be I1. This is the resultant of I2 dash and I0, which is I1. Now consider this equation. V1 is equal to minus E1. We have minus E1 here. Then plus I1 into R1. We have to add I1 R1 to minus E1. So we have to draw I1 into R1 here. I1 into R1 will be parallel with I1 because I1 into R1 is the voltage drop across R1. Voltage drop across the resistor will be parallel with the current phasor. So draw I1 into R1 parallel with I1. Now I got I1 into R1 like this. Then consider the equation V1 is equal to minus E1 plus I1 R1 plus J I1 X1. This J is for representing 90-degree phase shift. Voltage drop across the inductor will lead the current by 90 degree. So I1 into X1 will be in perpendicular with I1. So draw I1 into X1 in perpendicular with I1. This will be I1 into X1. J I1 X1 will be 90 degree with I1 or will be perpendicular to I1 into R1. Now we have to draw the resultant of these three minus E1, I1 R1, J I1 X1. Resultant will be this one. Sum of these three vectors. This is V1. So we got phasor V1. So the primary side is completed. Now consider the secondary side. V2 is equal to E2 minus I2 R2 minus J I2 X2. Here we have V2 here. Now we have to add, or we have okay, this is the equation. From here we can write E2. Write the equation for E2. E2 is equal to V2 plus I2 R2 plus J I2 X2. So we have V2 here. Now add I2 R2. So we have to draw I2 into R2 here. I2 into R2 will come like this because it should be parallel with I2. This is I2 into R2. Now we have to draw JI2 X2, which will lead I2 by 90 degree. So I2 X2 will be like this, JI2 X2. So this is the phasor diagram when when the load is purely resistive load. Now let's draw the phasor diagram when the load is inductive load. Flux phi in x-axis, E1, E2 minus E1, V2 and I0 are drawn, similar to that in the case for resistive load. Now here our load is inductive load. We know that for an inductive load, load current will lag load voltage by an angle. So V2 is the voltage across the load. So I2 will come like this. Here I2 lags V2 by an angle phi. Now everything as before, draw I2 dash. In order to draw I2 dash, extend I2 to the negative side. I2 lags V2 by an angle phi 2. Now in order to get I2 dash, extend I2 to the negative side. I2 negative of I2 is I2 dash. Now next step is to draw the resultant of I0 and I2 dash, which will be I1. So in order to get the resultant, construct a parallelogram with sides I0 and I2 dash. Resultant of this parallelogram will be the primary current I1. Diagonal of this parallelogram will be resultant of I0 and I2 dash, which is equal to I1. Now we have to consider the previous equation. V1 is equal to E1, negative of E1, plus I1 R1 plus J I1 X1. So I1 R1 will be like this. I1 R1 should be parallel with I1. So draw I1 R1 parallel with I1. We will get I1 R1 like this. Then we have to draw I1 into X1, which will be 90 degree with I1. I1 X1, J I1 X1 will be 90 degree with I1 R1, or will be 90 degree with I1. Now draw the resultant of minus E1 I1 R1 and J I1 X1. This will be the resultant, which is V1. Now the same process in the secondary side also. In the secondary side we have V2. Secondary side equation is this one. E2 is equal to V2 plus I2R2 plus JI2X2. So at the tip of V2, draw I2R2. I2R2, we know that I2R2 will be parallel to I2. These two should be parallel with each other. Then draw I2X2 perpendicular with it. I2X2, JI2X2. This angle should be 90 degree. Now resultant of V2, I2R2 and I2X2 will be E2. This is E2. This is the Phasor diagram for purely inductive load. Now consider the case of purely capacitive load, and coming to the case of purely capacitive load, it's not purely capacitive load, capacitive load. Capacitive load means it will be leading power factor load. Power factor will be leading. Inductive load means power factor will be lagging. So lagging power factor load means inductive load. Flux phi in x-axis. E1, E2, minus E1 and V2 are drawn like in the previous cases. Now we have to draw I2. Here we are having capacitive load or leading power factor load, which means the current I2 should lead V2. So I2 will come like this. This is I2. I2 should lead V2 by an angle phi 2. Then no load current I0 should be drawn. I0 like in the previous cases. Now draw I2 dash. In order to get I2 dash, extend I2 to the negative side and get I2 dash. Now this dotted line gives I2 dash. Now we have to draw I1. In order to get I1, construct a parallelogram with sides I0 and I2 dash. Parallel to I2 dash. Draw it parallel to I0. We got the parallelogram now. Now draw the diagonal of the parallelogram, which will be our current I1. So we got I1 like this. Now draw I1 into R1 at the tip of minus E1. I1 into R1 will be parallel with I1. So draw I1 R1 parallel with I1. I1 R1. This both should be parallel. Then with 90 degree with it, draw I1 X1. This angle should be 90 degree. Ji1 X1. Now draw the resultant for the three vectors minus E1, I1 R1 and Ji1 X1. This will be applied voltage V. Now the same thing to the secondary side also. I2 R2 parallel with I2. I2 X2 90 degree with it. Ji2 X2. Now resultant of V2, I2 R2 and I2 X2 will give E2. So these are the phasor diagram for single phase transformer at all the loads. Okay, thank you.